Hi and welcome to this Thiosulfate redox titration question. It's from question 18 on the OCR periodic table elements in physical chemistry, autumn 2021 paper. So let's have a look at the question first. Quite a lot of information to try and assimilate, so let's try and take it one step at a time. So what I'm going to do is highlight the steps that each part of the question is directing me to. So in step 1, the student observed the bubbles of gas were produced. So it talks about adding an excess of 1 nitric acid to 2.50 grams of a copper ore, and the copper 2 compounds in the ore react, forming aqueous copper 2 nitrate. So there's a gas formed. So a bit of recall here: carbonates react with acids to form carbon dioxide. So writing the full equation for the reaction, the formula would be CuCO3, and the equation would look something like that. Then it asks you to write an ionic equation including the state symbols for the reaction at step 3. So let's first of all think about what's actually going to react. So you've got copper nitrate reacting potassium iodide to make copper 1 iodide, CuI, as a solid, I2 in aqueous solution, and you can make 4 potassium nitrates. I put the potassium nitrates in because obviously the potassium has to go somewhere and the nitrates have to go somewhere as well. I'm a bit limited in the time I can spend in the video, since it's a little timer, so I'm not talking through where the balancing numbers came from, so hopefully you can kind of come along with me in that. So the next thing to do is to break everything that's aqueous into its ions, apart from the iodine, of course, which is covalent, and then we can get rid of anything that turns up on both sides, which allows us to put the appropriate ionic equation in. Suitable indicator for this titration is an iodine-based titration, so it's obviously going to be starch solution, and if you recall, the colour is go from blue-black to colourless. So the next thing they want you to do is determine the potential by mass of copper in the copper ore, and there's 2 parts of the question we need to focus on, so I'm going to change the screen a little bit and just pop them up the top there so we can work from them. So I'm going to advocate here the data moles equation moles answer technique, so it allows us to process the relevant parts one at a time. So looking at the information on sodium thiosulfate, we know that the volume is 26.55. The concentration is 0.02 moles per decimeter cubed. So what we can do is work that out using N equals C times V, and we get 5.31 times 10 to the minus 4 moles. Now, the equation we're using is not just that single one there, but also one we worked out ourselves a bit earlier. And what you've got to do is try to relate the thiosulfate to copper, which came from the ore in the first place. So looking at the Cu2 plus and the S2O3 2 minus, you can see that they have a 1-to-1 ratio. So therefore, it's the same number of moles of copper 2 plus. So that came from 2.50 grams of the copper ore, if you remember the question earlier. So that must mean the moles of copper 2 plus in the ore sample is going to be 5.31 times 10 to the minus 4 as well. So we want the mass of the copper in the ore sample, that's 63.5 over 5.31 times 10 to the minus 4, giving us 0.33785, and dividing that by 2.50 and multiplying by 100, we get 1.34874. Now everything is in significant figures here, so the least sensitive number of sig figs is 3, so therefore we go for 1.35. Now, finally, it asks you to explain whether the calculated percentage by mass of copper would be higher or lower, or the same. So if the potassium iodide is not in excess, there's less I- available, so you have a smaller titer as there's less iodine made, so you'll get a lower percentage by mass calculated. If you think about the burette readings, each titration is done by difference, so two separate burette readings are made, and the difference between them gives us the titration measurement. So if you make the same mistake on both readings, then the difference between them is not going to change. So therefore there's going to be no change at all to percentage by mass of copper or anything else for that matter. So in the final part, we've got the variety of possibilities, and it asks for what further modifications should the student use to make a more suitable or accurate value for the percentage by mass of copper in the ore. The student uses 25 grams copper, so it's a bit more, to make a standard solution, so you can do repeat titrations, or you can use a smaller concentration of S2O3 2 minus, increasing titer size, reducing potential uncertainty. Okay, thanks for listening, and see you soon.